Okay, air traffic controllers monitor the space around an airport. Okay, an air traffic controller monitors the space around an airport by keeping track of various airplane locations and movements using a radar screen like the one shown below. At the center of the grid is the air traffic control tower. So right here is the control tower, okay? The radius of each surrounding ring increases by 5 miles. When an airplane enters the tower's airspace, it is seen on the grid by a bright point called a screen pixel. So every one of those rings represents a radius of 5 miles. So this whole ring means I'm 5 miles away from the tower. And then 10, 15, 20. Everybody understand what they're trying to let us know there? Okay. An airplane is 15 miles away from the tower. Show all the possible locations of the plane. So if we know the plane is 15 miles away, where could the plane be? Yep. Right here, I'm drawing it in purple. The airplane could be anywhere on this ring. Any questions there? I'm going to say in purple. Okay. Because this information alone is not enough to locate the airplane, controllers also mark locations with an angle that is measured counterclockwise from due east. Does that sound familiar? Counterclockwise is this direction from due east, which is here. It's essentially how we rotate on the unit circle, right? No difference there. Plot a point that represents the location of an airplane 15 miles away and is 2 pi over 3 radians from the tower. So each one of these, if this is 0, look at how many we're dividing it into. So this is 1, 2, 3, 4, 5, 6. So it's in sixth is the way I think about it. So that means this one would be pi over 6 here. This would be 2 pi over 6, 3 pi over 6, 4 pi over 6. Huh? And so 2 pi over 3, that's the same thing as 4 pi over 6. So that means if the airplane is on this, it rotated this amount, and it's also 15 miles away, which is where we were drawing the purple. That means the airplane has to be where I'm drawing right here in blue. Right, it's 15 miles away from the tower, and it's rotation of 2 pi over 3 from due east. Questions? 3. Hot air balloons are not allowed within 20 miles of an airport for safety reasons. If a hot air balloon is identified on the radar screen, police must be notified of its location. The police must be given rectangular north, south, east, west directions in reference to the control tower to find the possible offender on their GPS. If a hot air balloon on the radar screen is at the point shown, what coordinate should the air traffic controller give the police? I.e., how many miles north, south, and how many miles east, west is the balloon from the tower? So what we're basically doing now is we're going to take something that's in polar and we're going to convert it to rectangular coordinates. Have you guys ever heard rectangular coordinates before? Okay. That's just your regular XY coordinate plane. I need to know how far left or right, how far up or down. That's called rectangular coordinates. Is that what they used here? They use a different, yeah, they use that terminology. So think about, let me erase some of this. I'm still recording, so it'll still be on there. Okay, think about your normal XY coordinate plane. So this is my x-axis. This is my y-axis. And so I want to know how far left, how far down do I go for the balloon. So let's figure out what we know about the balloon right now in polar coordinates. So how far is the balloon from the tower right now? 35 miles. So that means that the distance from here to here is 35. Everybody okay with that? Now, I really want to break that 35 into its X and Y coordinates. So think about what I'm looking for. I'm looking for how far left did I go? And I'm looking for how far south did I go? Well, what have I formed? A right triangle. OMG. And do I know what this angle is? What is it? Okay, so I agree. In total, I've rotated 7 pi over 6 to get there. Pi over 6 as my reference angle. So pi over 6 is the same as a 30-degree reference angle. Is everybody following what I'm putting down? And so if I wanted to find the blue side, that's essentially how far my Y value is. All right, so there's different ways you could do it. You could say, okay, let me just do it the formal way first. You could say sine of, I've rotated 210 degrees, right? Sine of 210, is everybody okay with where that comes from? I did 180. And then another 30. So or you could just leave it at 7 pi over 6. Okay, but in my brain, I make everything degrees to make sense of it. Sine of 210 equals, what's the opposite side? Y, what I'm looking for. What's the hypotenuse? And that's why I chose sine, because I knew the hypotenuse. I was looking for the opposite. So I was thinking, which one is opposite and hypotenuse? Right, that's literally why I picked sine. And so in my calculator, you could put that in. Sine of 210 equals y over 35. But this is one, they may make you do without a calculator. Right? So this is the formal way to teach it. If I was doing this one without a calculator, I know I'm really just finding sine of 30. Sine of 210 is sine of 30. Right? And sine of 30 is 1/2. But because I'm in quadrant 3, it is negative. Everybody okay? I know we're going back to unit circle.
So is that supposed to be all signs?
I know. No. I'm going back to right triangle trig. Oh, okay. I'm just going back to, law signs is dead to us. Okay. That's
pretty good at that.
Yeah, well that's good. That's good. It's over. So this is negative 1/2. It's what sine of 210 is, or sine of 30, would be equal to y over 35. I could cross multiply. So 2y equals negative 35. Divide by 2. Do you guys know what negative 35 over 2 is? Negative 17.5. Everybody okay? Everybody okay? Everybody okay? I was sine of 210. I was doing the same thing. Sine of 210 is in the third quadrant, and it has a reference angle of 30. So I was just doing my triangle from 30. That's why, in my head, when I see sine of 210, I just think sine of 30 in quadrant 3. But I could have just left it as sine of 210. I was just rusty on how I taught you guys this, so I should have just kept it like this, and I should have just drew my triangle. I shouldn't have ever written sine of 30 down. I'm sorry. I was writing what my brain does, where I shouldn't have done that. I should have just written it the way I've been doing it. But I'm out of practice. It's been like 3 weeks since I've taught any pre-cal. So,
I understand.
yeah. And that stupid law signs. I hate geometry. Okay. Now, I know the y coordinate is negative 17 and a half. Can I find the x coordinate, which is the red line? How? You could do the Pythagorean theorem. That's cool. That's cool. I wouldn't do it, but you could. I would do right triangle trig with cosine. But you could do either one. Do the Pythagorean theorem if you've got your calculator. Right? You may not be given the calculator though, right, on these kinds of problems. So if that is the side I'm looking for, it's adjacent, and I know the hypotenuse. So which trig function deals with adjacent and hypotenuse? It is cosine. So cosine of the angle 210 equals the x value over the hypotenuse. Cosine of 210 would be negative radical 3 over 2. We okay with that? Cross multiply. 2x equals negative 35 radical 3 divided by 2. So basically we've got negative 17.5 times radical 3, which I couldn't do that without a calculator. So they would definitely have you do a calculator on this part unless they accepted this, which they wouldn't. They would rather that be a number. So somebody with a calculator, have me a number. 30. They would on that. Negative 30 point. I'll tell you this. On your mock exam you took, the 3 polar questions were all non-calculator portion. There was none that I saw in the calculator portion, and there was none in the free response. There were 3 polar questions total. They were all multiple choice, no calculator. So that's why you've got to make sure you can do all of this part without a calculator. Sine 210, cosine 210. If they did this on a non-calculator part, this would be the answer they would want. Negative 35 radical 3 over 2. But in the way that it has been set up with us, how many miles north, south, east, or west? The way this is set up would be a calculator question. Because the police don't want to know it's negative 35 radical 3 over 2 miles to the west. They don't care. Okay. They would rather it be a number, which was negative 30 miles. 30 miles west, 17 and a half miles. The hot air balloon continues to move. By the time the police are able to catch up to the balloon, it is located 13 miles east and 15 miles south of the airport tower. Does this balloon violate the 20-mile limit? So how could I figure out? A triangle.
Could you do that?
Uh-huh. So if I am 13 miles east, that means I'm now on this side, right? 13 miles east of the tower, 15 miles south of the tower. And I'm looking for this distance. How far is it really from the airport tower? So I would do the Pythagorean theorem. So I'd be looking for the hypotenuse. So 13 squared plus 15 squared equals c squared. Take a square root. So I find c equals 849. So does it violate the 20-mile limit? I say barely. Is that what you said? Are we not a nation of laws? I mean barely. Yes. It's a violation. And the reason I'm really gung-ho about that is because on here they said, no, it's not a violation, which is just wrong. I don't know. They just were mixed up. It's a violation.
Well, is 5 miles over the speed limit a violation?
Are we not a nation of laws?
Depends on if you're around or not. You will get pulled over if
Yeah, no kidding. The answer is no, or not really. But wait, how many times are you going to hear that in presidential debates? Not politics, math class. What angle could be used to locate the balloon's new location on the radar grid? So thinking back, how much did I rotate to get here? I could find this angle, right? My reference angle. Because what sides do I know in relation to that angle? I know the opposite and the adjacent. You follow what I'm putting down? So which trig function deals with opposite and adjacent? Tangent. So I could say tangent of that angle has to be the opposite of 15 over the adjacent, which is 13. And now if I want to solve for tangent, why is tangent, if I want to solve for theta, why is theta not by itself? Because we're taking tangent of theta, so I can undo that with an inverse tangent of both sides. So I would do the inverse tangent of 15 over 13. I think you should get 0.857. Oh, and you know how I've told you guys to round to 4 decimal places? They will accept 3. I heard it from the chief guys himself. So 3 decimal places is what you're rounding to on all the free response. Okay? So if you put 4 like I taught you to, then you're good. If you put 2 and you needed 3, you're going to be wrong. What a shame. Did you guys get that? 0.857? So that means this angle is 0.57. So can somebody tell me how much did I rotate to get there?
you do 2 pi minus.
Uh-huh. 2 pi minus 0.857. Because all the way around would be 2 pi. And I think you should get something like 5.426. Yeah. Opinions. In elementary school, you learn how to graph real numbers on a number line. You guys remember that? Number line, just the x-axis. Later, you learn there were also complex numbers. Numbers that have real components and imaginary components. Do you guys remember what a complex number is?
I take the negative square root of a number.
5 plus radical 3i would be a complex number. It has a real part and it has an imaginary part. We would have done that this year in finding roots of polynomials. Right? You should have done a little bit with imaginary before that, but we did complex in the fall. So we learned there were complex numbers that have real parts and imaginary parts. Well, how do you graph a complex number? Right? So what we're going to do is we're going to show how you can graph them on a coordinate plane, a complex number. So consider the complex number 3 plus 2i. What is the real component of this number? 3. The real component is 3. What is the imaginary component? 2. 2 would be the imaginary component. The I is how we know it's imaginary. Okay? So in the complex plane, so we're no longer in the XY plane. We're not in a coordinate plane. We're in a complex plane. The horizontal axis, which is what you used to think of as the x-axis, we call that the real axis. And the vertical axis, which you think of as the y-axis, that is the imaginary axis. So we can graph a point, 3 plus 2i, on the complex plane by going right 3, up 2. Yeah.
So is this how it works on just any old X, Y?
That part is, yes.
Or is this a special?
We're fixing to turn this into polar again. Right? But for right now, the complex plane in rectangular coordinates, Cartesian coordinates would be at 3, 2. Questions so far? All right, now, what are the coordinates of this point in polar? So to get there in polar, I've got to think. I just went right 3. I went up 2. So I need to know what is the radius here, right, of that triangle. So I go r equals the square root of 3 squared plus 2 squared, which is radical 13. So we okay with that? And then I need to also know the theta. So I could say tangent of that angle theta equals the opposite over the adjacent. And so I would be going the inverse tangent of 2/3. This one would have to be a calculator. You couldn't find that one without a calculator. That's why did I do tangent? Because this is the angle I'm looking for. And I know the opposite and the adjacent. I picked tangent because of the sides I knew.
And what's the finding?
I'm finding this angle,
Oh, okay. Sorry. I could have used
right? Tangent of that angle is opposite and adjacent. I don't have to subtract anything because in polar, this is where I start. And so whatever angle I find is how much I've rotated total. Okay, so what do we get there?
0.588.
0.588. And so in polar, this would be radical 13 and 0.588. Everybody's changing classes. That makes me think I missed a text message. We are ready to move quietly. No talking in the halls. Go to second period. 4. A complex number can be represented using the point 4, 5 pi over 6 in polar coordinates. We want to graph that point in the complex plane above. So we're starting in polar. Radius is 4. That means I'm starting right here at 4. And then I'm rotating 5 pi over 6, which would put me here, right, is the 5 pi over 6 rotation. So my point would be right there for 4, 5 pi over 6. Any questions there? Okay, what is the real component? Well, how do I find my real component? Real component is the x value, essentially, right? So we could say the real component would be, how did we find the x yesterday? R cosine of theta. So in this case, that would be the r, which is 4, times cosine of theta, which is 5 pi over 6. So now what is cosine of 5 pi over 6? Negative radical 3 over 2. And again, you could draw that if you needed to. Hopefully we can do this kind of quickly in our heads more than having to draw the triangle each time. But if you can't, 5 pi over 6 means I rotated 150. 150 means a reference angle of 30. This would be 1 radical 3 and 2. And cosine is the adjacent over the hypotenuse. And because I'm in the second quadrant, cosine would be negative. All right, there's your quick review of how I got negative radical 3 over 2. But hopefully you could do that a little more quickly now. And then let's reduce this. So this is essentially 4 over 1 times radical 3 over 2. What do I do when I multiply fractions? Straight across. Thank you. No cross multiply. Thank goodness. I was trying to set you up. Okay, so I can, however, cross reduce, right? So 4 and 2 becomes 2 and 1. And then multiply straight across, that's going to be 2 times negative radical 3. So that means the real component is negative 2 radical 3. Again, this is something AP would expect you to do without a calculator. Questions about that? Next, how could I find the imaginary component? Well, the imaginary component is what we used to think of as the y value. How did I find the y values yesterday? R sine theta. Which means the radius is still 4. And we're going to be doing sine of 5 pi over 6. Which we know is this same triangle. Sine would be opposite over hypotenuse, which is 1/2. And because I'm in the second quadrant, it should be positive. So 4 times 1/2 is 2. So the real component is negative 2 radical 3. The imaginary component is 2. So write this as a complex number in Cartesian form, a plus bi. So all a is the real part. So what's the real part? Negative 2 radical 3 plus b is the imaginary part, which was 2 times I. That's my Cartesian number. Negative 2 radical 3 plus 2i. Just like the size or magnitude of a number in its absolute value, the magnitude of a complex number is its distance from the origin. So this is an idea with vectors. Did we do magnitude with vectors in 112? Or did we skip that part? We didn't talk about it. We did do
this direction.
Did we do vectors? Did we do like 2i plus 3j in 112? Trace, tell me no again. We did matrices. So we didn't look at vectors at all? Okay. So vectors are a lot of what we're doing right here. Right? If you ever have to take physics and you start learning about vectors, vectors have an I component and a j component. The I component is really just the x value. The j component is the y value, where the entire vector would be the hypotenuse, where you're breaking it into its two components. That's kind of what we're looking at here. Vectors have magnitude. All that is what is their real distance away from the origin. They're saying the absolute value of the magnitude or distance from 0. All we really want to know is what is the distance from the origin for this number. Right? So whenever you see the word magnitude, I want you to just think distance. Right? It's the same thing. So if I were to graph A minus, why did I say A? I'm losing my mind. If I was to graph 1 minus 4i, that means on the real axis, I'm going right 4. On the imaginary axis, I'm going down 4. And so you see I've got 2 components. I know the real component is 1. I know the imaginary component was -4. And if I want to know the magnitude, I'm really looking for the distance of this vector, or the distance of that line from the origin to that point. And I could find that by using the Pythagorean theorem, right? Nothing crazy here going on. And so we could say, let's just call that, they're using magnitude. Let me see if they use special quotes. They don't really. So if I wanted to find the distance, I could do the square root of a squared plus b squared. Right? I'm just finding the hypotenuse to a right triangle, guys. Nothing crazy. 1 plus 16, which is radical 17. So the hypotenuse, or the distance here, is radical 17. So the way that they write that, they write the absolute value of 3 plus 2i is radical 17. All absolute value is just its magnitude. Distance from 0. Right? You've only ever taken the absolute value of a real number before. Like the absolute value of -4 is 4 because it was straight this way. Right? There was no imaginary component. So now we're doing the absolute value of a complex number. We have to factor in the real part and the imaginary part. So to find its actual distance from 0, we have to do the Pythagorean theorem.
That's supposed to be 1 minus 4i, right? In the absolute value.
Yeah, I don't know why I put 3. Ignore me. I'll tell you why I wrote it, because that's what they wrote. I'm looking at the answer key. That'll get me in trouble. What would be the, let's just ask that, what would be the magnitude of 3 plus 2i? Yeah. Oh, did I do it again? I'm an idiot. Just... Look, it's been, look. How many days do we have left? 27 for me. Okay. 18 for y'all? Are y'all counting all the way to here? Or y'all counting to the 10? Wait, you're coming this way at 12. Pre-cal test at 12. Yeah, I mean, it's just... We'll have something fun. I'll get something. We'll have something. What was the magnitude of 3 plus 2i? Right, we just found that one earlier. So it's just the radius. It's just another way to do what we've already been doing. Right? Any questions?